The origin of culture and the emergence of Homo. Migrants and immigrants. Hominins evolved in Africa, yet today hominins are found on every continent. Humans first evolved in Africa, and much of human evolution occurred on that continent. The fossils of early humans who lived between 600,000 and 2 million years ago come entirely from Africa. We all know that before tayo maging kung anumang physical characteristic natin ngayon, ay marami munang process ng evolution ang nangyari. We became apes, chimpanzees, and gorilla before us humans. And upon studying the migrants and immigrants of Homo, we came across to the two questions. Who were the first hominins to leave Africa, and when did they first live? For many years, the clear answer was that the Homo erectus was the first to leave Africa, and they did so perhaps 700,000 to 1 million years ago. They may have been the first human species to leave Africa. Fossils remain showed this species have expanded its range into southern Eurasia by 1.75 million years ago. Researchers believe na ang Homo ergaster or African Homo erectus ang unang migrate out sa Africa. May mga evidences like fossil skull to prove na sila ang unang umalis sa Africa. New evidence strongly suggests that the human race migrated from its African cradle to Asia nearly 1 million years earlier than most scientists believe. The discovery will force anthropologists to re-examine some long-held beliefs about how and where evolutionary turning points made mankind master of the world. The first new information came from geochemist Carl Schweitzer, who in the mid-1990s redated the Java sites where Homo erectus fossils have been found and determined they dated to perhaps 1.8 million years ago. Because the earliest Homo erectus fossils in Africa share a similar date, this created a problem. The problem is, how did the Homo erectus appear in Java at about the same time they appeared in Africa? Carl Schweitzer presented the evidence saying that there is possible two or more Homo erectus species that evolve independently from a common ancestor. That's why meron evidence ng fossils ng Homo erectus sa Africa but at the same time meron din sa Java. As this question was being pondered, a remarkable set of new Homo erectus fossils were being uncovered in Dmanisi, Georgia. Dated at 1.7 million years ago, these fossils made it clear that Homo erectus left Africa almost as soon as they had evolved. The fossils that found in Dmanisi, Georgia is a skull. Dahil sa volume ng brain ng skull na almost half of modern human, and also they found 4 fossils, the upper part ng body na nagpapakita na nag-evolve na ang Homo erectus dahil sa more advanced spine and lower limbs, which is the reason kung bakit mas madaling kumilos. The discovery of Homo habilis-like fossils at Dmanisi, Georgia, China suggested that Homo habilis may have been the first to leave Africa and Homo erectus followed the path their predecessors blazed. If they were following an entire earlier migration, it could explain how Homo erectus were able to move quickly across Asia. The picture above is the fossils found in Dmanisi, Georgia, and the picture below is what Homo habilis look like. A more unusual source of information on when hominins first left Africa comes from the parasite that accompanied them. All hominids are plagued by lice, but humans host a distinct species, Pediculus humanus. Geneticist David Reed and his colleagues found that Pediculus humanus diverged from other lice about 5.6 million years ago, about the time the first hominids appear. More interesting, however, Reed and colleagues discovered that there are 2 subspecies of Pediculus humanus that appear to have diverged about 1.2 million years ago. One subspecies is found worldwide today, and the other is restricted to the New World. Tid and Collegio suggested that this is evidence that at least some hominins migrants, probably Homo erectus, became isolated in Asia by at least 1.2 million years ago, where their lies divergent from that of other hominins population. Head lice researcher Reed found out na mayroong dalawang uri ng head lice. Yung isa is nakita na nag-evolve sa ancestor of our species, which is Homo sapiens, and the other one is nakikita sa Americans and evolved Homo erectus, which, which is another early human species, but jumped to Homo sapiens about 25,000 years ago. Sinasabi na pwedeng maging evidence para malaman na some hominins migrants, probably Homo erectus, na na-isolated in Asia by at least 1.2 million years ago, where their lies is napasa sa ibang hominins, which is the Homo sapiens. So here's the question: who were the first hominins to leave Africa and when did they first live? So who are the first hominins migrants? They may have been Homo habilis or they may have been very early Homo erectus. So when did they first live? Probably slightly less than 2 million years ago, but once these hominins left, they moved quickly and they moved long distances. By 1.6 million years ago, Homo erectus was in both Western and Southern Asia. And by 1.2 million years ago, their population have moved far enough to have become isolated from one another. Whether or not they were the first migrants of Africa, Homo erectus migrated fast and far. The physical characteristic of Homo erectus. This picture example of Homo erectus skull. The Homo erectus skull generally was long, low, and thickly veiled, with a flat frontal area and prominent brow ridge. It had a unique pentagonal shape when looked at from the back, formed in part by a rounded ridge called a sagittal keel. Sagittal keel is an inverted V-shaped ridge running along the top of the skull in Homo erectus. There was also a ridge of bone running horizontally along the back of the skull called an occipital torus, which added to the skull's overall long shape. Occipital torus is a ridge of bone running horizontally across the back of the skull in apes and some hominins. Compared with early Homo, Homo erectus has relatively small teeth. Homo erectus was the first hominin to have third molars that were smaller than the second or first molars, as in modern humans. The molars also had an enlarged pulp cavity called taurodontism, which may have been allowed the teeth to withstand harder use and wear than the teeth of modern humans. Taurodontism is having teeth with an enlarged pulp cavity. But the Homo erectus jaw was lighter and thinner than in either early Homo or the Australopithecines, and the face was less prognathic. Prognathic is a physical feature that is sticking out or pushed forward, such as the faces in apes and some hominid species. The brain of Homo erectus, averaging 895 to 1040 cc, was larger than that found in any of the Australopithecines or early Homo species, but smaller than the average brain of a modern human. Homo erectus had a prominent projecting nose in contrast to the Australopithecines' not projecting nose. From the neck down, Homo erectus was practically indistinguishable from Homo sapiens. The almost complete skeleton of a boy at Nariketon is about 5.5 feet tall and about 80 years of age when he died. Researchers estimate that he would have been over 6 feet tall had he lived to maturity. Homo erectus in East Africa was similar in size to Africans today who live in a similarly open, dry environment. Homo erectus was also less sexually dimorphic than either the Australopithecines or early Homo. The degree of sexual dimorphism in Homo erectus was comparable to that in modern humans. Homo ergaster point to several differences between them and other Homo erectus populations. The cranial proportion differ in Homo ergaster. The brown ridge is thinner and is arched above each of the eye sockets. The eye sockets are more rounded, and the face is oriented more vertically below the skull, among others. On the other hand, some scholars believe that the differences between Homo erectus and modern humans are not large enough to be identified as different species, and they argued that Homo erectus population should be lumped into Homo sapiens. This forfeiture of different kind of hominids. Next is the Homo floresiensis. Most anthropologists agree that Homo floresiensis is a distinct species that is closely related to Homo erectus. Homo floresiensis has only been found on the Indonesian island of Flores, and only a handful of individuals have been located to date. All are tiny, fair, 3 feet tall, and have very small brains, on the order of 360 cc. The structure of the brain, however, seems closely related to that of Homo erectus, as do the structure of the skull. Homo floresiensis appear to be a tiny version of Homo erectus. Homo floresiensis even made tools that look similar to those made by Homo erectus, and in some cases, the tools look even more sophisticated. So although they were small in stature and have very small brains, Homo floresiensis seems to have been culturally and intellectually similar to Homo erectus. The body of Homo floresiensis also seems to resemble Homo erectus, or perhaps even the Homo habilis. And if the Homo floresiensis appear to be a tiny version of Homo erectus, how might a miniature version of Homo erectus have evolved? Dwarfism appeared to be an adaptation that occurs when there are few predators. A species in isolation can become smaller and have a large population if there are no predators threatening them. This may be what happened on Flores. It is interesting that the island also hosted a number of dwarf species in addition to Homo floresiensis, including a dwarf elephant that appeared to have been one of the favorite food of Homo floresiensis. Perhaps even more interesting in the fact that Homo floresiensis may have been survived until as recently as 12,000 years ago, well into the time period when modern humans were living in Indonesia. The evolution of Homo erectus. The evolution of Homo erectus reflects a continuation of a general evolutionary trend we discussed previously. The brain continued to expand, increasing more than a third over early Homo. The face, teeth, and jaws continued to shrink, taking on an almost modern form. An increasing use and variety of tools may have been led to a further development of the brain. Homo erectus is an apparent reduction in the extent of sexual dimorphism to almost modern levels. The Australopithecines and early Homo were quite sexually dimorphic. Homo erectus does not have appeared to be sexually dimorphic as these early hominids. What might cause of this change? Sexual dimorphism appeared to be linked to social system in which males are on the top of dominance hierarchies due to physical size and prowess, and such males control sexual access to multiple females in the group. Another question is, could male-female bonding have developed in Homo erectus? It seems possible. Recall that the early Homo have been established some of the basic elements of human culture, including home bases or meeting places, family groups, and sharing. Another basic element of present human culture, one is that the present in almost all known culture, is marriage. Marriage is a socially recognized sexual and economic bond between two individuals, typically a male and a female. This is intended to continue throughout the lifetime of the individuals and to produce socially accepted children. It is a specific kind of pair bond with a set of behaviors, expectation, and obligation that extend beyond the pair of those individuals' families. With marriage, then, the competition between males for access to females may have been diminished, lessening the importance of sexual dimorphism. But why might marriage have developed in Homo erectus? In animal species where females can feed themselves and their baby after birth, pair bonding is rare. But in a species where females cannot feed both themselves and their baby, pair bonding is common. A strong male-female bond provides a good solution to the problem of incompatibility between mother's feeding requirements and tending a newborn baby. A male partner can bring food and watch the newborn while the mother gets food. But most primates lack pair bonding. This may be because primate infants are able to cling to their mother's fur soon after birth so that the mother's hands can feed forage. Human infants demonstrate a residual form of this innate ability to cling during their first few weeks of life. This is called the Moro reflex. If an infant feels at its falling backward, it will automatically stretch out its arm and clench its fists. The brain in Homo erectus may also have already expanded enough that Homo erectus infants, like modern human infants, could not adequately support their heads even if they could hold onto their mother's fur. When early hominins began to depend on scavenging and hunting for food, it would have been difficult and hazardous for a parent with a newborn baby to engage with these activities with the baby along. Marriage could have been an effective solution to this problem because each parent could help protect the baby while the other was away getting food. Another important aspect of the evolution of Homo erectus was the movement of population out of eastern and southern Africa. Upon entering new environment, Homo erectus would have been faced with the new climate condition, new and different sources of raw materials of tools, and new plants and animals to rely on for food. All animals adapt to such changes through natural selection, but natural selection typically takes a relatively long time and requires physical changes in the adapting organism. Homo erectus was able to adapt a new environment very quickly and without apparent physical changes. What cultural adaptation might Homo erectus have made? Fire might have been the crucial cultural adaptation to colder climates. But fire can only warm people when they are stationary. It does not help when people are out collecting food. To be mobile in colder climates, Homo erectus may have been began to wear animal furs for warmth. Some Homo erectus tools look like the hide processing tools used by most recent human groups, and it seems unlikely that Homo erectus would have survived in the colder location where they have been found in Eastern Europe and Asia without some form of clothing. And if Homo erectus was wearing furs for warmth, they must have been hunting. Homo erectus needing skins would have had to kill fur-bearing animals themselves if they wanted to intact skins and furs for clothing. Fossils remains themselves cannot provide evidence for whether or not Homo erectus was hairless. Current research and issues. How do we construct ancient environment? How do we know when past environments look like? The answer is provided by the field of paleobotany, paleozoology, and paleoclimatology. Paleobotany uses plant remains found in archaeological and fossil sites to identify the range of flora in a location at a given point in time. These plant remains usually include preserved seeds, pollens, and paleontoliths, which are small pieces of silicon that develop between plant stems. Phytoliths are unique to particular plant species, and since they are essentially small rocks, they preserve very well. Plant can also fossilize. By looking all of these types of plants remains, paleobotanists can often provide a very clear picture of a flora that once existed in a given area. And paleobotany is the study of fossils plants. Paleozoologists examine the animal remains and fossils from site to determine the type of animal that once inhabited a given location. Many of the more important animals are small rodents, reptiles, snails, and the like, which are highly sensitive to environment changes. Like plants, animals are adapted to particular environment. So the animals found can give a clear indication of past environment. Paleology dealing with ancients and fossils animals. Paleoclimatologists use evidence provided by paleobotanists and paleozoologists to develop a basic picture of a climate that once existed in a given area, but also employ unique evidence of their own. One type of evidence is the grow rings of trees, which are thicker and when there are more rainfall and thinner when there are less. For more global climate reconstruction, researchers look for the material trapped in glacial ice cores, deep sea sediments, and cave splodens to provide information on the composition of the atmosphere. Combining all this information, researchers can develop a very accurate picture of what the environment in a given area was like at a given point in time and can also trace environment change over time. Next is the Lower Paleolithic culture. The stone tool tradition of Homo erectus is traditionally called Lower Paleolithic. This stone tools tradition involved core tool techniques in which a core of a stone rather than a flake is used as the basic raw materials for finished tools. Because stone tools are the most common cultural material in the archaeological records of the Asian people, the entire culture of Homo erectus is often tempered Lower Paleolithic, a practice we follow here. The archaeological finds a tool and other cultural artifacts dating from 1.5 million years to about 200 years ago are assumed to have been produced by Homo erectus. But hominin fossils are not usually associated with these materials. Therefore, some of the tools during this period were possibly produced by hominins other than Homo erectus, such as Australopithecines earlier and Homo sapiens later. Acheulean tool assemblages dating from 1.5 million years ago to more than a million years later are very similar to each other, and Homo erectus is the only hominin that spans the entire period. Thus, it's conventionally assumed that Homo erectus was responsible for most of it. Not all the Acheulean tools assemblers were described. The Acheulean tool tradition. The stone tool making tradition, known as the Acheulean, was named after the site of Saint Achel, France, where the first examples were found. But the oldest Acheulean tools recovered are from the East Africa on the Penich River, Tanzania, dating back about 1.5 million years. In contrast to all the one Acheulean assembles have more large tools created according to the standard design or shapes. Many of these tools were made from a very large flakes that had first been struck from very large core or board. One of the most characteristic and common tools in the Australian toolkit is the so-called hand axe, which is a teardrop-shaped, fishery flake tool with a thin, sharp tip. Other large look tools resemble clevers and picks. There were also many kinds of flakes tools, such as scrapers with a wide edge. Earlier Cholan tools appear to have been made by a blown with a hard stone, but later tools are wider and flatter that may have been made with a soft hammer or bone or antlet. This soft hammer techniques of making stone tools was an important innovation. Tools made by a hard hammer technique, rocks against rocks, have limits in terms of their sharpness and form because only large and thick flakes can be made with a hard hammer techniques. Lawrence Cayley microscopically examines some Acheulean hand axes, and the wear on them is more consistent with animal butchery. They may also have been used for hardworking, particularly hollowing and shaping woods, and they are also good for digging. William Calvin has even suggested that a hand axe could be used as a projectile throw like a discus into a herd of animals in the hope of injuring or killing an animal. Acheulean tools are found widely in Africa, Europe, and Western Asia, but bifacial hand axes, cleavers, and picks are not found as commonly in Eastern and Southeastern Asia, because Homo erectus have been found in all areas of the Old World. It is puzzling that the tool tradition seems to differ from west to east. Some archaeologists have suggested that large bifacial tools may be lacking in Eastern and Southeastern Asia because Homo erectus in Asia had a better material to make tools out of bamboo. Bamboo has been used recently in Southeast Asia for many purposes, including incredibly sharp arrows and stick for digging and cutting. Geoffrey Pope has shown that bamboo is found precisely in those areas for Asia where hand axes and other large facial tools are largely missing. Big game eating. Some of the Australian sites have produced evidence of a big game eating. Clark Howell, who excavated sites at Torralba and Ambrona, Spain, found a substantial number of elephants' remains and unmistakable evidence of human presence in the form of tools. Howell suggests that the human of those sites used fire to frighten elephants into muddy bogs from which they would be enabled to escape. To hunt elephants in this way, the human would have had to plant and work cooperatively in fairly large groups. Some archaeologists who have reanalyzed the evidence from Torralba think that the big game may have been scavenged because the Torralba and Ambrona sites are near ancient stream. Many of the elephants could have died naturally, their bones accumulating in certain spots because of the flow of water. What seems fairly clear is that the human did deliberately butcher different kinds of game. Different types of tools are found with different types of animals. Thus, whether the human hunted big game at Torralba and Ambrona is debatable, all we can be sure of as of now is that they consume big game and probably hunting smaller game. The control of fire. Homo erectus is thought to have hunted apes by using fire drives, a technique still used by hunting and gathering people in recent time. It is highly effective. Animals are driven out of their hiding places and home by fire and dispatched by hunters positioned downwind of the oncoming flames. Most of people who use this technique today set fire deliberately, but fire caused the lightning strike may have been also been utilized. Homo erectus was the first hominin to be found throughout the Old World and in an area with freezing winters. Most anthropologists presume that Homo erectus have learned to control fire, at least for warmth. There are archaeological evidence of fire in some early sites, but fires can be unnatural events. Most persuasive evidence of human control of fire, dating from nearly 800,000 years ago, comes from a site of Jesher Benot in Israel. Researchers found out evidence of burned seeds, woods, and stone, as well as concentration of burned items suggestive of hearts. The evidence of control of fire at Jesher Benot and the European sites is not associated with Homo erectus fossils, so the link between deliberate use of fire and Homo erectus cannot definitely be established yet. The lack of clear evidence does not, of course, mean that Homo erectus did not use fire. After all, Homo erectus did move into cold areas of the world, and it is hard to imagine how that could have happened without the deliberate use of fire. If Homo erectus were relatively hairless, clothing therefore may have been necessary, but fire might have been even more important, and not only for warmth. cooking would be possible. The control of fire was a major step in increasing the energy under human control. Cooking would have made all kinds of food more safely digestible and therefore more usable. Fires would also have kept predators away, and not inconsiderable advantage given that there were many. Next is campsites. Achelian sites were usually located close to water sources, lush vegetation, and large stock of herbivorous animals. Some camps have been found in caves, but most were in open areas surrounded by a rudimentary fortification or windbreaks. Several African sites are marked by snowy rubble brought there by Homo erectus, possibly for the dual purpose of securing the windbreak and providing ammunition in case of a sudden attack. The presumed base campsite display a wide variety of tools indicating that the camp was the center of many group functions. More specialized sites away from a camp have also been found. They are marked by a predominance of a particular type of tool. For example, a butchering site in Tanzania contained dismembered hippopotamus carcasses and rare heavy-duty smashing and cutting tools. Workshops are another kind of specialized sites encountered with some regularity. They are characterized by tool debris and are located close to a source of natural stone suitable for tool making. A camp has been excavated at the Terra Amata site near Nice on the French Riviera. The camp appears to have been occupied in the late spring or early summer, judging by the pollen found in fossilized human feces. The excavator describes stakes holes driven into the sand, paralleled by a line of stone, presumably making the spot where the people constructed huts of roughly 30 feet by 15 feet. A basic feature of each hut was a central heart that seems to have been protected from drafts by a small vault built just outside the northeast corner of the hearth. The evidence suggests that the Terra Amata occupied gathered seafoods such as oyster and mussels and did some fishing, and hunted in the surrounding area. Some of Hunt's contain recognizable toolmakers areas scattered with tool debris. Occasionally, the impression of an animal's skin show where the toolmaker actually sat. Religion and ritual. Questions like what belief did Homo erectus hold about the world around them? Did they take part in ritual? Did Homo erectus have religion? Remains of red ochre or oxidized clay have been found on a number of lower Paleolithic sites. This may have been significant because in many later cultures, even modern ones, red ochre have been used in rituals of various types of represent blood or more generally life. Ochre seems to have particularly important in burial rituals, and human remains sprinkled with red ochre have been found in many parts of the world, dating as back as the Middle Paleolithic. However, there is no evidence that Homo erectus buried their dead or nor any evidence that ochre was used in rituals. Zhoukoudian in northern China that some of the Homo erectus remains there showed evidence of ritual cannibalism. The foramen magnum of some specimens have been deliberately enlarged and the facial bones have been deliberately broken away from the cranium on others. A possible reason may have been to remove the brain for ritual consumption. Ritual cannibalism have been widely reported among living people, so its presence among ancient people is not impossible. At this point, we simply cannot say whether religion or ritual were parts of lower Paleolithic culture. And that's what my report all about, and now we will proceed to question time. For code number 6, based on the gathered information, who are the hominins that first lived Africa? For code number 10, is the Homo erectus hairless? For code number 48, what is the stone tool tradition of Homo erectus traditionally called? Thank you.